find the complete integral of z square equal to pqxy. So for this, let's take the function f to be equal to, I am taking this right hand side to the left hand side. That is z square minus pqxy. And now we need to use the Charpit auxiliary equations. For that, we need these details first. Derivating f with respect to x is minus pqy. Derivating f with respect to y is minus pqx. Derivating f with respect to p is minus qxy, and with respect to q it becomes minus pxy, and with respect to z it is 2z. And now using all these details in the Charpit auxiliary equations, that is this. So from here we get dx divided by fp. Fp is derivating f with respect to p. So we have this to be minus qxy. So this is minus qxy equals to dy divided by fq. So that is minus pxy. Then is dz divided by p multiplied with fp. So this is already fp, I am multiplying this p. So this is minus pqxy plus q multiplied by fq. This is fq. So because I am having minus sign over here, I am writing here negative sign, multiplying q with this. So this is pqxy and is equal to dp divided by negative of fx. Fx is minus pqy plus p multiplied with fz. Fz is 2z and is equal to dq divided by minus f of y, which is minus pqx plus q multiplied with fz. So this is 2qz. This is 2pz. Very fine. Okay. Now we need to choose such kind of two ratios so that we can get the value of p or q from this. Or you can choose such kind of two ratios so that you can get the relation between p and q, right? Our purpose is to find the values of p and q. So which one is the easier one? We can choose the ratio. Okay, I'm having qxy over here and pqy over here. If I multiply this denominator with x and multiply this denominator with p, we get here pqxy with negative sign, and here we can get the positive sign pqxy, so that we can easily cancel these two when we add these two ratios together. If I take the multiplier p with dx, if I take the multiplier x with dp, yes, so what I'm getting? I'm getting here pxqy with negative sign plus here I get pqxy with positive sign, and when x multiplied with the second term we get minus 2xpz. So we have here pqxy minus 2xpz. So we can easily cancel these two and we get in the denominator minus 2xpz. We can equate this ratio with, in the same way, if I take the multiplier q over here, I get in the denominator minus pqxy, and taking the multiplier y over here, and in the denominator I get pqxy minus 2qyz. I'm going to add these two ratios. So equating this 2, we can cancel 2 from this, z, and also the negative sign. So we have xp and qy only in the denominator. So we can write the numerator as the derivative of xp. In the denominator we have xp equals to, we can write here the numerator as the derivative of qy, and in the denominator we have qy. So integrating both the sides we get log of xp equals to log of qy plus log of the constant c. So that is, if I take this to the other side, I get log of xp divided by qy equals to log of c. So this gives xp is equal to cqy, where c is a constant. So we have got the relationship between p and q, right? To get the values of p and q, we are going to use the given equation z square equal to pqxy. To get the value of p, we can use this equation in this. So we have xp is equal to c. Just put the value of q from this. We get z square divided by pxy into y. So these two cancelled out, and we have, taking px to the other side, we have p square x square is equal to cz square. Because c is a constant, I can take this to be as c1 square. Taking the constant c to be c1 square. Why I have taken the square? So that I can get easily the value of p as c1z divided by x. We are having square on every variable. That is why we have taken the square on the constant. So this is the value of p in terms of x and z. Whatever in terms of the variable you get the value of p. Similarly, we can get the value of q to be equal to, if I put the value of p from this given equation into this equation, z divided by c1y. So this is the value for q. And now third step, we have to use the equation dz equal to p dx plus q dy. For the complete integral, we have to get the value of z. So putting the value of p over here, we get c1z by x, and then putting the value of q to be z divided by c1y dy. We can take z common from these two terms, and taking that z to the denominator of dz, and here we have c1 by x dx plus 1 divided by c1y dy. And now integrating, we get log of z to be equal to, this is c1 log of x plus 1 divided by c1 can be taken as, okay, let me write this as c1 inverse log of y plus log of c2, the constant. So we have log of z to be equal to log of, by using the property, x power c1 multiplied with y power c1 inverse multiplied with c2, or z is equal to x power c1 into y power 1 divided by c1 into c2 is the required complete integral. Alright, thank you.